Okay, today we're going to talk about the water cycle, which is a topic that you have had in elementary school, but we go a little deeper and we go a little bit more complex once we get in sixth grade. So let's start off by just reviewing what we talked about up to this point about the water that is on Earth. If you recall, we looked at a pie graph and we all guessed, and we said how much of the water on Earth is divided into those three categories of salt water, fresh water, and then frozen fresh water. And we learned that of the water on Earth, 97% of it is salt water, which is in the oceans full of lots of salt. We can take the salt out of that water, but it's very expensive, so it's just not really something that we can do at this point and make it affordable. So we have 97% of the salt water, and that leaves 3% left. And remember, of that 3%, 2% is frozen in glaciers. We can't just go and turn on the faucet and get that out because it's frozen in our glaciers. So that leaves, of the water that's left on Earth, 1%. That 1% is our lakes, our rivers, our creeks, our streams, the groundwater underground, all the water that we can actually use as humans for all of our needs. Taking a bath, cooking, washing our hands, swimming, all the fun stuff as well. So we go down here, we say, so of all the water on Earth, 99.7% is not even usable by humans. So that leaves less than 1% that we could actually use. So we have to take care of it, and we find out that it goes through the water cycle. So when we look at the water cycle, here's some interesting questions. It says, this one, did you know that you are drinking George Washington's bath water? Okay, that's a long time ago. How could you be drinking his bath water? Well, it's the same water. The water that's on Earth today is the same water that has been here forever. As long as the Earth has been created, we have the same water. So we don't make new water. The same water that you take a bath in may be the water that was deep in a glacier millions of years ago. Or it may have been what the dinosaurs swam in. Or it may have been part of the Nile River. So it's the same water. It just goes through the water cycle. So we're going to start off with a little video about the water cycle. Just watch, nothing to write down at this point.
Water is as old as the Earth. As far as we know, the amount of water on Earth has never changed. That's amazing when you think that the water in your faucet may have been deep in the sea millions of years ago, or it may have been in a glacier for 1,000 years. When you are done with it, it goes down the drain and sooner or later back to a lake or ocean where it may rise up into the sky and form a cloud that travels around the world to be used again. All over the planet, the sun helps nature recycle water in the water cycle. The water cycle has three main parts. Evaporation is when water turns into invisible water vapor and rises into the air. Condensation is when water vapor forms clouds, dew, or frost. And precipitation is when water falls from clouds as rain, snow, sleet, or hail. There's also a fourth part to the water cycle. It's called runoff, and that's when water runs downhill to flow into streams, lakes, or oceans. In the water cycle, we see water's different forms and properties. It can be solid ice that does not change shape, liquid water that moves and flows, or water vapor that floats in the air. The parts of the water cycle can control the climate of cities worldwide. Some places stay warm and wet, while others stay cold and dry. The water cycle is like an engine, and the fuel for it is heat from the sun. The more heat that comes from the sun, the faster the water cycle works. At night, and even in places where you don't have much heat, the water cycle continues as liquid water changes to ice or water vapor, and back again. We call these phase changes. The water cycle makes sure that clean water falls from the sky and is spread around the earth in one way or another. This makes it possible for people, plants, insects, and animals to survive and live almost anywhere.
Okay, so let's look at your notes. In that very top part, beside the sun, it says water never leaves the earth. It is constantly being recycled through the atmosphere, oceans, and land. This process, known as the water cycle, is driven by energy from look at the picture, the sun. The water cycle is crucial to the existence of life on our planet. So you can pause the video at this point to fill in those. If you need to rewind, you can do that. And I will continue. So let's look at some different diagrams of the water cycle. You can go to Google and find all kinds of images, some simple, some a little more complicated. So I'm going to briefly explain this and then talk about each process more in depth. So because it's a cycle, it doesn't have a starting point or an ending point. It just keeps going. But we will start right here in a body of water. This could be a lake, this could be an ocean, this could be a puddle in the parking lot or in your driveway. And so we have liquid water. And if heat is added to that liquid water, it doesn't have to be much heat, but the more heat, the more this happens, then that liquid water will turn into water vapor. Okay, so it'll go from liquid water to water vapor if heat is added. And normally the heat is the sun, but sometimes there's heat from other sources. So it turns into water vapor, and we call that evaporation. So evaporation is a process of liquid water turning into water vapor when it's heated up. So then we have all kinds of water vapor in the air. It doesn't have to be outside. It can be inside, in a classroom, in your house. And sometimes you can feel it, especially in the summertime when it's so sticky and humid. That's because there's a lot of water vapor. And that makes sense because there's a lot more heat from the sun, so this process is happening much faster. So you have water vapor in the air. Well, as that water vapor rises up, the temperature is going to drop and it's going to start getting cooler. So anytime you have water vapor getting colder and cooler, it's going to turn back into liquid water. So when water vapor cools down and turns back into liquid water, we call that process condensation. Okay? So you have liquid water in the air, and those liquid water drops come together. And when they come together, they form clouds. So all those clouds that you see in the sky are basically liquid drops of water that have joined together. Well, and they'll stay that way until they get too full, too heavy, and gravity causes them to fall. So when the cloud gets too heavy and water or snow or sleet or hail starts coming out of it because it can't hold it anymore, we call that precipitation. So precipitation is simply when the liquid water falls. And like I said, sometimes it's not liquid, sometimes it's frozen as snow, sleet, or ice, and it falls. Now, because 3/4 of the earth is covered with water, most of the time that precipitation falls on the ocean. But sometimes it actually falls on the surface of the earth, which we know that when it rains. If it falls on the surface, then it usually will go through a process called runoff, and runoff is basically where it goes downhill. Falls on a mountain, that's pretty obvious. But eventually the runoff it'll run off the surface and go to a creek, a stream. The streams usually lead to a river. The river eventually leads back to the ocean where it is stored. Sometimes it just takes it to a lake and it's stored there. But wherever the water is stored, we call that accumulation or collection. Over here, let's talk about this word transpiration. Transpiration it's a type of evaporation, but it comes from plants and trees. So evaporation is when water leaves a plant, such as a tree, and it turns into water vapor. Okay, if you've ever seen plants, maybe you go out in the morning and you see little drops of water on the edges of the leaves, then that is water leaving that plant through the process called transpiration. If you have house plants at your house, if you ever look at them closely, you'll see that there's little drops of water on the tips of the leaves, and that is water leaving the plant, and it turns into water vapor. But we call it transpiration. Okay. The next picture is it's a very simplified water cycle, but you have your sun, which powers it. The sun heats up the liquid water, turns it into water vapor, evaporation. A cloud is formed, and we have water vapor turning back into liquid water, condensation. The cloud gets too full, and it releases that water. We call that precipitation, and then back down here in the ocean is collection. But remember, collection can be a lake or an ocean, just somewhere where the water collects and is stored. Here's a little bit more complicated one. Kind of check it out and see. We got snow, we've got an ocean over here, we've got a mountain. So we'll start out with our ocean, and you see the sun is what powers the whole water cycle. So we have water evaporating and turning from liquid water into water vapor, it cooling back down and turning back into liquid water, so that's condensation. And sometimes it stays in our atmosphere for a while in the form of clouds. And then when those clouds get too full, we get precipitation. If it stays up here on the mountain, it's just going to kind of store there a while until there's enough heat to melt it. Sometimes it runs off as the snow melts. We didn't talk about this before, but a lot of times the water will go underground. It just seeps into the ground through the layers of the soil, and we call that infiltration, where it goes down under and becomes our groundwater, which then people who have wells will use that water to drink from. Sometimes it will stay there. Sometimes it will come out at a spring. If you've ever been hiking on the mountain and see a spring coming out, that's the groundwater coming out through an opening. Here we got some storage of the fresh water, so a lake. So you can have evaporation from the lake as well. Let's see. Surface runoff, where it's just running downhill back to our ocean. And I'm going to stop this one at this point because we're about at the 15-minute mark, and pick up with evaporation and the video and fill in our notes there.